Hi guys, welcome to Science in 5. In this video we're going to discuss the kinetic molecular theory of matter. We'll aim to address one of the questions that says, well, what is the behavior of matter at a molecular or particle level? In other words, matter is made up of molecules or particles. How do they behave? The kinetic theory of matter states that matter is made up of small particles that are in constant motion, and this motion has consequences. In other words, when the materials move faster, what happens? When materials tend to move slower, what happens? At a lower temperature, what is the motion of particles like? How do we compare this motion to the same particles when they are at a higher temperature? Again, observe lower temperature. Now, higher temperature. We can clearly see that at a higher temperature, the particles move faster. There is more motion, okay? So this is what we're talking about. And this idea that a higher temperature involves particles moving faster is what we're going to be exploring in this video. At some temperature, the particles seem to stop completely. Well, the particles seem to have zero kinetic energy. This simply means there is no motion at all. Kinetic energy is the energy that an object has because of its motion. So if a particle has zero kinetic energy, it means it is not able to move at all. Now, this happens at a special temperature. We call this temperature absolute zero. At absolute zero, all particles of matter have zero kinetic energy. They cannot move. Now, in degrees Celsius, the temperature value of absolute zero is minus 273 degrees Celsius. Using another temperature scale called the Kelvin, the absolute zero temperature value is 0. So we say it's 0 Kelvin. Now, don't be worried about converting between Kelvin and degrees Celsius. It's a very easy process. If you've got a temperature in Kelvin, or you've got a temperature in degrees Celsius that you want to convert into Kelvin, rather, what do? Well, the temperature in Kelvin is simply equal to the temperature in degrees Celsius plus 273. So to convert into Kelvin from degrees Celsius, just take the value that you have in degrees Celsius, add 273. To convert the temperature from Kelvin to degrees Celsius, all you have to do is take your temperature value in Kelvin, subtract 273, and you get your temperature now in degrees Celsius. Now, kinetic energy is equal to the half times mass times the speed squared of an object or particle. Okay? Now, if the mass remains at a set value or is constant, there is a relationship between the speed and the kinetic energy. We say the kinetic energy is directly proportional to the squared speed. What does this mean? Well, it simply means an increase in speed means an increase in the average kinetic energies of particles. And the converse is true. A decrease in speed means a decrease in the average kinetic energies of particles. What are we measuring when we measure temperature? Well, a simple answer says the degree of hotness or coldness of a medium. A better answer says the average kinetic energy of the particles of a system. So when we're measuring temperature, we're actually measuring the average kinetic energy of the particles of a system. When the temperature is higher, the particles are moving faster. Temperature is lower, the particles are moving slower. Okay, so at a higher temperature, we know that the speed is going to be very high, which means the particles have more kinetic energy. At a lower temperature, it simply means the particles are going to be moving much slower, and consequently they will have a lower amount of kinetic energy. In the solid phase, the particles are held together by strong forces of attraction. There are very small spaces between particles. Particles are not free to move and can only vibrate. Adding more heat will increase the frequency of vibration, and this can lead to melting of the solid. Well, solids are rigid, have a definite volume, and cannot take shape of any container. In the liquid phase, the forces of attraction are weaker than in solids, but stronger than in gases. The particles are free to move and can slide past each other. There are more spaces between particles. Although liquids cannot be compressed, they can take the shape of the container. Very important property of liquids is that they cannot be compressed. In the gaseous phase, the forces of attraction are very weak. The particles have large spaces between them and move at very high speeds. The gases can be compressed. If you take a pure substance and you start heating it from its solid phase, it might convert into a liquid and then into a gas. Not all materials will do that, but most pure materials actually do that. They go from solid to liquid to gas. A good example is water. Frozen water is called ice. You can heat the ice, it becomes a liquid water. The liquid water, you keep heating it, it will become gaseous water. So the name of the process where a solid converts into a liquid is called melting. Melting requires heat energy. So the solid must absorb heat energy and then it can convert into a liquid. You carry on heating a liquid, some of the particles of the liquid gain enough energy, they become a gas. We call that process vaporization. Now, the reverse process can also take place. If you cool down a gas, it can condense and it becomes a liquid. We call that process condensation. If you continue to cool a liquid again, it will reach a point where it begins to solidify and converts into a solid. We call that process freezing. Now, some materials can skip between the solid and the gas phase without necessarily going into the liquid phase. So the conversion of a solid into a gas phase directly is called sublimation. Iodine is an example of a material that can sublime. Dry ice or carbon dioxide is also another example of a material that can sublime. Materials can also move from the gaseous phase into the solid phase. We call that deposition. That's it, guys, about the kinetic molecular theory of matter. I hope you understand the basics now. I hope you enjoyed this video as we discussed the basics of the kinetic molecular theory. The idea that matter is always moving and that motion has consequences. It can lead to the material being in a solid phase, in a liquid phase, or in a gaseous phase, depending on the strength of forces and the temperature at which you subject the material. In the next phase, we're going to take a closer look at what happens during the phase changes. What happens to the average kinetic energies of the particles. Thanks for watching, guys. It's been a pleasure. See you guys next time.